Alrighty, everybody, we are moving on. We're talking about the nervous system today. So 2.2 big ideas are going to be all around these systems. Okay, this is a biggie. This is the organization of our nervous system. Okay, and this is something you're absolutely going to have to know. So be prepared. This might be a little bit of a longer one, but hopefully it's one that you get down because we are going to use this material all year. We're going to come back to these systems, and you're going to have to know what system was involved in certain processing, in certain decision making, in certain thinking. Definitely something you should know. So be prepared. Here we go. The nervous system primarily is broken down into two parts, two things you need to know. You've got the central nervous system and the peripheral nervous system. Okay, on one side, the central nervous system, this is one you often hear about. This is your brain and your spinal cord. Okay, this is your decision maker. This is your command center. This is where the magic happens, right? Your body does nothing without the central nervous system. Okay, the central nervous system is ultimately what is commanding and controlling everything else. This is, no pun intended, the brains behind the operation of our body. Okay, so brain and spinal cord, it is controlling everything that's happening in the body. Okay, outside of that, right, we have other nerves and neurons that are all working together to do things in the body. And you see here the brain and the spinal cord, they can't do anything, right? Like your spine isn't going to like move around on its own and be able to do a whole lot, right? We have these limbs, we have fingers, we have toes, we have feet, arms, legs, all of these that move around, and they give us the ability to move around. That's not something that's in the central nervous system. The central nervous controls that and helps us move those things around and tells us when I'm consciously thinking, move this around. It's the central nervous system that's thinking that, but it's the peripheral nervous system that's doing it. Okay. The peripheral nervous system is doing two things. It's two-way communication. It's both receiving information, right? Receiving information. Clearly, if I like come up here and make contact with my webcam, then I am receiving information for what that feels like. I'm sending that information through my peripheral nervous system, my skin touching that. The nerves, the sensory neurons in there are receiving that information, sending it back to my central nervous system so that I can then process and think about it. Right? Both of them work together. The peripheral nervous system is gathering information, and then it does whatever the central nervous system says. Right? My central nervous system decided I needed to move up and feel the webcam, and when I did that, I decided and then thought about like, hey, this is soft, right? This is softer than I thought it was going to be actually. But then I realized I'm blocking the webcam. I need to move it. And the central nervous system told my hand to move it back. So we both communicated what the webcam felt like up to my brain. And then when my brain told it to move, it moved back. So it's two ways of communication. It's both sending messages to the central nervous system and also doing whatever the central nervous system tells it to. Okay. The peripheral nervous system is primarily made up of these nerves, and these are just cords of axons wrapped together. Okay, lots and lots of axons wrapped together. Some of these are very thick, as large as like the sciatica nerve. You could literally like pinch between your hands. And it runs like the length of your entire leg, right? So central nervous system, brain, and spinal cord, peripheral nervous system is just the kind of action portion of that. And this is the general organization structure that you should know, right? The nervous system is both of these things. The central nervous system, you see that on the left, brain and spinal cord. The peripheral nervous system, you see that on the right. The central nervous system, it doesn't break down any further, right? It breaks down into brain and spinal cord, but they're all ultimately kind of doing the same thing, at least in the nervous system. They are deciding and figuring out what to do, and they are communicating. They're receiving information from the peripheral nervous system. They're processing it, thinking about what to do, and then they're sending information back out. Okay, and so we're going to talk about each one of them as we go, but you should probably recognize how the peripheral nervous system is further broken down. All right, this peripheral nervous system branches into two pieces, the autonomic and the somatic. We'll talk about those in a minute, but the biggie is autonomic. Think about it, it's automatic. It happens without our ability to like control it, right? We can't like tell our heart like, hey, I'd like you to beat faster now. We can do some things that'll make it happen, but I can't think, heart, please stop beating, and just think it and will that to happen, right? We don't really control those things. Somatic is more the things that we have control over, right? Sensory are voluntary muscles, right? I'm controlling my muscles, my bones, my arms, my feet, my head when I'm moving around and talking. So autonomic's automatic. Somatic is things that we control. Automatic, autonomic breaks down into sympathetic and parasympathetic. Sympathetic being fight or flight, arousing. Parasympathetic is calming or rest and digest. We'll talk about those in a minute. And then somatic breaks down into sensory and motor neurons. So this is basically the input output. Okay, so let's talk about all of those. We're going to start with the somatic and autonomic nervous systems, portions of the peripheral nervous system. So remember, peripheral nervous system breaks into these two, autonomic and somatic. We're going to talk about those first. Big idea, somatic is the voluntary control, okay? Voluntary. If it's something that you chose to do, it is somatic. If it is something that's happening automatically, ANS, autonomic, automatically autonomic, somatic, skeletal. You're trying to remember this through a mnemonic. The autonomic is happening automatically. Like internal organs, things like our heart, our lungs, right? We can hold our breath, and if you pass out from holding your breath, your body will start breathing again, right? You can't actually stop yourself from breathing unless you put yourself in an environment with no air, right? Our body is to some extent on autopilot. I'm not sitting here and thinking, all right, heart keep beating, lungs keep breathing. I need brain to be processing glutamate for me so that I can form these thoughts and from that stuff's happening automatically, right? Autonomically, autonomic nervous system is happening automatically. Okay, internal organs. All of my organs are doing what they're supposed to. Peripheral nervous system is controlling that, but it's doing it without my control. It's on autopilot. Autopilot, autonomic, automatic. Okay, autonomic nervous system. Somatic, it's skeletal, meaning it's voluntary, right? Think about moving around by choice. That is the somatic nervous system. Okay, so let's go a little bit further down. Somatic nervous system, autonomic system. Autonomic breaks into sympathetic and parasympathetic. Okay, autonomic, remember this is the automatic one. So these automatically, we've got two systems even within autonomic, broken down into sympathetic and parasympathetic. Sympathetic is your fight or flight response. This is, instead if we're talking neurotransmitters, remember those, things like acetylcholine, norepinephrine and epinephrine, right? Also known as adrenaline. Whenever we come across a bear, or thousands of years ago, a saber-toothed tiger, and we're like, this thing's going to kill me, our body kicks into fight or flight mode. And we either like, I've got to fight this thing, or I've got to run away. And so the sympathetic nervous system automatically, we can't be like, hey, I don't need to do this. Our body does it automatically. Okay. Our heartbeat increases so that we can pump blood faster. Our blood pressure increases. Our blood sugar increases. Like we've got all of these things increasing so that we can do what we need, right? Adrenaline, we can fight or we can run away. Our digestion stops, because the idea is if you're running, you don't need to be digesting. Your body's using energy to burn basically to digest your food and work it through. It's going to stop doing that because it's like, we've got to get away from this bear. Otherwise, we're going to become food. So I'm going to stop digesting food. So it doesn't do that. And we start sweating, right? When you get really nervous, you start sweating. Why? Because you're getting ready to run, right? You're getting ready to run away or to fight. Sweat is something that cools you down. You start sweating when you're nervous because your body's trying to cool down in preparation for that. Okay. So to remember that, I often think like sympathy, you would feel sympathetic for someone that is in danger, and your sympathetic nervous system is firing whenever you are nervous, okay, or whenever you're in danger. So feel sympathy for that person whose sympathetic nervous system is activated. Okay. On the flip side, the parasympathetic nervous system, this one is rest and digest. So when we're chilling, parasympathetic is at work. Okay, so this is calming you down after fight or flight, or in just a normal state, your parasympathetic nervous system is at work. It's going to help you sleep. It's going to help you digest food. You ever notice that when you're really stressed about something, if that maintains for too long, you get a tummy ache, right? Your stomach hurts. You get gas pains. You can't digest your food. You're not eating. Why? Because you're in fight or flight mode. Your body's not digesting food. You need to calm down so that you can actually digest food, because your body isn't meant to maintain stress. So meditate, do what it takes, but you got to get your body into that parasympathetic nervous system so that you don't live permanently in the sympathetic nervous system stage. And then a good mnemonic or memory trick, a paramedic is on the way, so you can calm down. So chill. paramedic is here. A paramedic is going to make everything all right. They'll help you calm down. Okay. Parasympathetic, rest and digest. Sympathetic, fight or flight. And these are both a part of the autonomic nervous system. So again, sympathetic, parasympathetic are a part of autonomic, which is also a part of peripheral. So finally, the somatic nervous system is what you really should recognize here are the different types of neurons, because what the somatic nervous system does is it's dealing again with our ability to move, right? Our ability to control our motions in some way. But we've got three types of neurons here that we need to know because these are all necessary. Hopefully, we're going to be better at this. We've talked so far about some of the different ways of what happens whenever you see something scary. So this is a great example of that, right? What happens when when your hand touches a hot stove, or when you like in Home Alone step on a nail? Here's the actual ins and outs of what's happening, right? So we talked about how a neuron fires. These are the types of neurons that you need to know. So in the somatic nervous system, you've got sensory, motor, and interneurons. Okay, so here's a diagram. You've got one sensory neurons. Okay, so here is when you're touching something sharp, right? Or in this case, looks like a flame, right? You touch a match, a super hot match. What's the first thing that happens? Right, most people, you notice that your hand flicks back, right? But sometimes before you even notice it, right? You have this reflex quickly. What is a reflex? How does that happen? You've got these sensory neurons that receive the message like, that's super hot, that's not good. So it's blasting the message up, and then it's going to be received by an interneuron. Think of an interneuron as like an intermediary, a middleman. The interneurons are in your spinal cord, and they are a part of the central nervous system. Okay. Right, and they are going to help make the decision, right? They're the neurons. They're a part of the somatic nervous system as well. But they are chilling in the central nervous system's like structure. They're in the spinal cord. And so they are communicating with both the central nervous system and the somatic nervous system. The sensory neurons touch something hot. They blast the message up to the interneuron in your spinal cord, and the spinal cord sends it to two places at once. It sends that message both up the spinal cord to your brain for processing, but it's also sending that message out to your motor neurons to quickly move your hand back. That's why reflexes happen before you can process things, right? Before you can process the fact that this is hot, I should move my hand back. Your hand's already moved back, and then you're like, ow, that was hot, right? Because your interneurons sent a motor neurons that said move at the same time as it was sending a message up to your brain for you to process, right? So sensory neurons come from our fingers. They work up through our arms into the interneurons in our spinal cord for processing. The interneurons, the middleman is going to send the message, still sensory, the interneuron up the brain, up towards the brain, and it receives that information. Okay, we'll talk about the parts of the brain later in the year and what that looks like, but receives the information in the brain. And then if it's not super painful, right, if it doesn't hurt, the brain can then decide, I don't need to be touching this anymore, or I've processed this, I can move it back. And it can send out the motor neurons that say, please remove your arms. But if it's super hot and you can't, those motor or efferent neurons are going to have to quickly act before the brain even processes it. So sensory neuron receives the message of the fire up to the interneuron sends it both to the brain and to the motor neurons, which say, ouch, quickly remove the hand from the fire. Okay, so that's what a reflex is happening within those interneurons. But those are kind of the intermediary that determines, and it's like a gate that figures out what to do with the message and where it needs to go. So sensory senses, they're also called afferent, meaning that they're going to be arriving. If we're thinking about the central nervous system as like the brain and spinal cord as the centerpiece here, the sensory nerves are going to send things up to the brain. They are afferent, meaning that they're going to arrive. Okay, they're also afferent. You could see either of these terms on the AP Psych test. Afferent neurons. The other ones, the efferent or motor neurons. These are efferent, as in they exit the central nervous system and then tell your hands to move. Okay. The final one, this may not pop up in this unit. We'll probably talk about this one a little bit later in the year, a little bit more, but just know that there is another type of neuron that pops up in the brain that is a more recent discovery known as motor or mirror neurons, a fascinating kind of claim that this is really what differentiates humans from so many other species and what allowed us to kind of evolve while other species did not, is that we have an incredible ability for mimicry. Right. And so mirror neurons are these specific neurons that fire when we're watching another person do something. And oftentimes these mirror neurons light up and then they start lighting up other parts of the brain as if you were doing something. How is it that you all can sit around and watch somebody play video games, stream Fortnite or whatever for 10, 15, 20 hours at a time? Right? You could be playing it. Why wouldn't you? Why would you do that when you could just? Why would you be watching someone play video games when you could do that? Because of mirror neurons, right? Why do we watch sports? Why do we enjoy sports? Because of mirror neurons. We especially like the sports. We watch the sports that we like playing because our brain activates and we imagine ourselves doing that. And it's a mirror neuron that does that, that allows us to mimic and gives us like joy and enjoyment when we're watching someone else do something that we enjoy as well. Some animals do this, right? Monkeys have some mirror neurons, even dogs have some mirror neurons, but like humans have it at a level that no other creature even comes close to. Right? We are incredible species when it comes to mimicry. Right? We are very, very skilled at that in a way that no other animal does. Right? Even to the point that it's unnecessary. Studies have shown that monkeys will like take the fastest route and ignore if the person in front of they watch a monkey go through an elaborate set of steps to get a ball, and what the monkey will do is they will just go in and get the ball or food or whatever the reward is. A human that watches another human do it will watch all of the elaborate steps and then to get that food, and they could have just gotten the food, but they go and do all of the elaborate steps as well. We tend to mimic even when it's unnecessary. So mirror neurons, just recognize that there is another portion. We'll talk about these a little bit more later in the year. They'll pop up in other units, but it helps us understand others. And then oftentimes a malfunction of mirror neurons is one of the assumptions of kind of the claims. I mean, this is still kind of early science. We're not completely sure on this. The findings are still not 100%, but they're predictions, hypotheses, theories that malfunction of the mirror neuron is responsible for autism. All right. So that's that. Calling it a day there. The endocrine lecture will be much shorter. I can promise you that. But until next time, I will see you then.